In this lecture, we will learn about the chain of responsibility design pattern and how to implement it in Python. Chain of responsibility is a behavioral design pattern. We use it to achieve loose coupling in software design, where a request from the client is passed to a chain of objects to process it. This design pattern lets us pass requests along a chain of handlers. When do we use chain of responsibility? This pattern comes in handy when our program is expected to process different kinds of requests in various ways, but the exact type of requests and their sequences are unknown beforehand. We can also use this pattern when it is essential to execute several handlers in a particular order, or when the set of handlers and their order are supposed to change at runtime. Let's look at the pros and cons of using the chain of responsibility pattern. The pros of using the chain of responsibility pattern are that you can control the order of request handling, you can decouple classes that invoke operations from classes that perform operations, and you can introduce new handlers into the app without breaking the existing client code. The drawback of using this pattern is that some requests may end up unhandled. Let's learn how to implement the chain of responsibility pattern in Python. Up at the top of the code, we will import the time module. Let's create a class named handlerBase. Inside of this class, we will create a variable named nextContestant, which we will initialize to a value of none, and a variable named question, which we will initialize to a value of none. Then we will define the init function for this class, which will take in three parameters: self, nextHandler, and question. Inside of this function, we will set self.nextContestant equal to nextHandler, and self.question equal to question. Next, we will define a handleRequest function that takes in a parameter named self. Inside of this function, we will use the pass keyword. Then we will create a contestant1 class that will extend our handlerBase class. Inside of this class, we will implement the init function that will take in three parameters: self, nextHandler, and question. Inside of the init function, we will set self.nextContestant equal to nextHandler, and self.question equal to question. Then we will define a handleRequest function that takes in one parameter, self. Inside of this function, we will print out question, and then pass in self.question. Then we will print a dashed line to separate the question from the contestant's responses. After that, we will print the message waiting for contestant 1 to respond. Then we will call time.sleep and pass in 1 to make the code wait for 1 second before continuing to execute. Then we will print the string no response from contestant 1 to the console. Finally, we will call self.nextContestant.handleRequest. Next, we will create a class named contestant2 that extends the handlerBase class. Inside of this class, we will implement the init function, which takes in three parameters: self, nextHandler, and question. Inside of the init function, we will set self.nextContestant equal to nextHandler, and self.question equal to question. Then we will create a function named handleRequest that takes in the self parameter. Inside of this function, we will print the message waiting for contestant 2 to respond. Then we will call time.sleep and pass in 1. After that, we will print no response from contestant 2 to the console. Then we will call self.nextContestant.handleRequest. Time to create a contestant3 class that extends the handlerBase class. Inside of this class, we will define the init function that takes in three parameters: self, nextHandler, and question. Inside of the init function, we will set self.nextContestant equal to nextHandler, and we will also set self.question equal to question. Next, we will create a function named handleRequest that takes in the self parameter. Inside of this function, we will print the message waiting for contestant 3 to respond. Then we will call time.sleep and pass in a value of 1. After that, we will print the message no response from contestant 3 as well. Now let's create a class named context_object. Inside of this class, we will define an init function that takes in two parameters: self and question. Inside of the init function, we will set self.question equal to question. Time to test our code. First, we will create a variable named question, which we will set equal to a context object with the string "who was the first president of the United States" passed in. Then we will create a variable named contestant3, set equal to a contestant3 object with none passed in as the first argument, and question passed in as the second argument. Next, we will create a variable named contestant2, set equal to a contestant2 object with contestant3 passed in as the first argument, and question passed in as the second argument. After that, we will create a variable named contestant1 that will be set equal to a new contestant1 object with contestant2 passed in as the first argument and question passed in as the second argument. Finally, we will call contestant1.handleRequest. When we run the code, Notice that each contestant has an opportunity to respond to the question in order, thanks to the chain of responsibility design pattern that we implemented. In the next lecture, we will learn about the command design pattern and how to implement it in Python.